Alright guys, we are going to look at some waveforms now. You guys should already be familiar with this stuff. Okay, before we get started, I want to just say that now this video shouldn't last no more than an hour. I'm just joking, guys. Hopefully this video it's not going to be that long. And while we're here, we'll kind of do a little tutorial stuff, you know, kind of things I'll point out maybe if you're not familiar with the software. If you look down here at the very bottom, you see where it says notes. You can see I've got everything labeled out there for you. So this here channel A, if you remember, that's the 18x signal off the crank signal. The red trace, that is going to be the 3x sync signal coming off the crank position sensor. And down on the green there, we are looking at the 18x reference signal. Remember, that's coming out of the ICM going to the PCM. That's where I actually measured this, if you remember, right there at the ICM connector. And the one on the bottom is the 3x reference signal measured at the ICM, again output going to the PCM. All right, what do you think? You see anything wrong in there? Looks okay to me, huh? Well, look, while we're here, let's talk about the waveform buffer up here. If you look right here, this is a waveform buffer index. You'll see that I have 31 captures right now. Now I can step back through these, and as we're stepping back, take a look at the waveform, see if you see anything out of the ordinary. See if you see any dropout, something that looks a little different from other pulses here. So we're going to go through these, okay? And everything to me looks good, which is kind of what we expected anyway. Let's take a look at some of these voltage measurements. Okay, if you look over here on the left hand side, you see these here blue vertical numbers there. These blue vertical numbers are the voltage scale. If you look right there, you can see that's 0. There's 0 volts here representing on the bottom of these pulses. And if you look up at the top, we can estimate, you know, between 4 and 8. So it looks around about 6. Okay. Well, why don't we just go ahead and we'll measure that. So what we're going to do is I'm going to grab this here little blue square and I'm going to drag it down, and I'm going to kind of put it right down there on the bottom. Okay. Now if you look here, it says 32.13 millivolts. Now you see I just clicked in there, but really I wanted 0 volts. So let's type in there. Let's type 0, and that's going to take that dash line and it's going to set it down there at 0 volts. Alright, well, let's go up here and let's drag the blue. Let's put it up here near the top, and let's look over here. We look at this very last one here. That's the delta. That's the difference between the 0 volts and the 6.608. So you can see that we got about 6.6 volts. In fact, it may look like I might be a little bit high. So yeah, there we go. Okay, 6.5 volts. And that's pretty much what I said in the discussions in the previous videos. Okay. All right, let's do the same thing for the red. We're going to quickly go through them. I'm going to put my line down here, go up here, click in there. I'm going to make it 0 volts. I'm going to get my next one here. I'm going to drag it, put it on the top. And as you can see, 6.5 volts. All right, let's do the same for the green. I'm going to get the green, going to put them down. Now let me show you this. So what if I put it right there and I want it to go to 0? Just to show you, if I put that in there, click in it, hit 0, see how it snaps right down to the 0 volt line. All right, let's go up here, grab another green, put him there. And as you can see, he is pretty darn close to 5 volts, and that's what we said in our discussions earlier. So right there is showing 4.9 volts. And the last one here is the gold, or the yellow one. Let's put 0 volts down there, click up there, put a 0, and one more time pull it down. Let's get our there, and as you can see, those voltages looks pretty good. 4.9 volts. We'll pretty much say they are 5 volts. All right, so that looks all good to me. All right, now one of the things, if you remember, before we go any further, now you guys has already seen this, but you know, you can take and look at waveforms by taking these here voltage scales, and you can just click on this red one that I'm gonna move, so I can move it up and down. So if I drag the mouse, I can move it up, and you notice I can push it right anywhere I want. And if you remember how we were looking at those transitions, okay, Now before I zoom in, here's our zoom tools right up here. This right here is a zoom full, so if I click on it, it'll go to all the way out to the max. And if I want to say zoom in, if I go right there, and then if I come in somewhere, let's say right there, and I click, then it'll zoom in right there where the little magnifying glass is at. And if I go back and hit the minus and then it'll just zoom back out. And of course I can go back to zoom full. Now this one right over here is my favorite. It's the window zoom tool. So if I click there, and you remember the little transitions here, first narrow, next the biggest, and here, so I can zoom around there. Anywhere in that little zoom window is what I'm going to see. It's going to blow it up, and there it is. And of course you can see the transitions. There's 1, there's a 2, and there's a 3. Now we've already talked about that, but I'm just kind of demonstrating PicoScope a little bit here for you, just kind of showing you some of the stuff here. So we can go back, and I can take my trace, I'll push him on back down where he was. Alright, so you remember the code said P0336 that it actually looks at the ratio between the 18x reference signal and the 3x reference signal. That's between these here two traces. That's that green, and that's this gold one down here. Well, you know, let's take a look at that. Let's see if we do have that that reference. Oh, I don't know. Let's put the first one right here. I'm lining it up on that. Notice right away you can see how this is lined up right there on that edge. And let's get another one here. So now what I'm going to do is an easy way to do this. You can look at the low, see what part of the waveform is low, or you can count the ones that's high. So if I got a 18 to 3, 18 pulses up here, remember 18 pulses per crank, and then that means I'm going to have 3 pulses over here per crank. So what I'm going to do is I'm going to count the low. That'll be 1, that'll be 2, and that'll be 3. So I'm going to say there's 1, there's 2, there's 3, and then I should finish up right on, let's see, 1, 2, 3. It should be right. Let me get it lined up. Okay, that's 3 pulses. All right, so if I got 1, 2, 3 low, and if I count the highs, it don't matter. 1, 2, 3. And if I count the pulses, there's 1, there's 2, there's 3. So it doesn't matter. Now, let me zoom in just a little bit more. Oh, let's do it like right there. All right, so if I have 3 pulses here, how many should I have up there? I should have 18. So if you want to count the pulses or count the highs and count the lows, either one. I'll count the highs this time. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if you want to count the lows, it'll be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so our ratio is correct. It looks like it's 6 to 1. So at this point right now, at the ICM, where these two signals are being measured at, that looks fine. Now, we don't know what's happening at the PCM, so that's where in the next video, we're going to move over to the PCM, and we're going to look at these signals again, and we're going to make sure that they are correct over there. Now, if you know, I've already mentioned this here between these here two dashed lines here, these two measuring lines. You remember that's one, that is 1 revolution of the crank. Well, one of the little features here, once you mark out, say, 1 revolution of your crank, if you take a look down here, look in the lower right corner, right there where I've marked out right there, you can see I'm running at 832.41 RPM. Okay, so that's a little nice feature also. So we can zoom back out again. So we can just go ahead and also if you look right up here, you can see that for that revolution, 1 revolution of the crank, if you look up there, you can see that it took 72 milliseconds. Okay, all right. Well, I guess one of the things we could talk about too is sample rate. This right here is your sample rate up here. So basically it's how many samples a second it's going to take, you know, so you can carry this thing all the way up. I think it's a 2 giga samples a second. Well, let's see what it'll take us to. So yeah, 2 gig samples a second. Okay. Over here, this is our time, you know, how much time we're going to put on the screen. So right now it's 20 milliseconds per division. And what they mean by division is time, as you know, on oscilloscope runs horizontal, voltage runs vertical. And also, before some of the people that don't know about the oscilloscope, and I probably should have mentioned this up front, oscilloscope is nothing but a voltmeter. It's just measuring voltage over time. Think of this right now that I got 4 voltmeters hooked up on there, and I'm looking at these all 4 signals at the same time. So basically think of it like 4 voltmeters. All right. Now the time, getting back to the 20 milliseconds per division, if you look down here, look, you remember time goes horizontal, and if you look down here at the very, very bottom, you see where it starts time at the far left corner down here where it says 0, and then you see the next division is 20. Well, it is 20 milliseconds. The next one's going to be 40, and it runs all the way across to 200. So that's 200 milliseconds across the entire screen, because I got 10 divisions here, 10 little graticals if you want to count them, and then 10 times 20 milliseconds gives me a total time of 200 milliseconds. Now guys, this is what's amazing to me. This scope, let me show you what kind of time. Most scopes ain't going to give you this kind of time basis here, right? You'll see maybe up something like, you know, maybe 1 second, 2 seconds, right? But look at this right here. We're going down 10 seconds, 50 seconds, 100 seconds, and we're still going down. Look, 5,000 seconds per division, right? Now total time, how much is that? That's 5,000 seconds times 10 graticals. That is 50,000 seconds for a total a screen capture, a window, right? 50,000 seconds. If you divide that out, you're going to get close to 14 hours. Now here's the amazing part: 14 hours. And how many times can we sample a voltage? In other words, how much time is going to go between each point before we're going to say, all right, I'm going to take a voltage, take a voltage, take a voltage. We can do that at 14 hours. We can do that 2/1000ths of a second. That's just amazing. Even at that long time base, you know, in 2/1000ths of a second. Now, of course, depending on what you're looking at, but you know, not too much is going to get away from you. So I mean, you could set this thing up for logging, you know, if you wanted to look at something that long. I never had a need to, you know, but let's just show you some of the power that you got here. Some other things we got is, you know, you can set your range for your voltage, right? You got all of these different voltage ranges, and you notice now you got these ranges, but hey, you can define your own. If you don't like the plus and the minus, and let's say, hey, you know what, I just want 0 to 10 volts, I don't want no negative volts. Well, you can set it up, you can customize it to whatever range you want. Okay, I'm just using the ones that's already built in there, and they've been good enough for me. And of course you got different couplings, AC, DC, typical, and here's where you can set your probes up, what type you want. You got all kinds in there. So you got there's a WPS pressure transducer, there's stuff in there for that. Attenuators, you know, if you're going to be looking at fuel injectors, or if you're going to be looking at the primary, say, of your ignition coil, you got your amp probes, got 2 different ranges, or 2 different types, several ranges. Got a 60 amp, you got a 2000 amp, got a 600 amp, and you got your also, here's one thing too. You remember we was talking about the waste spark ignition? Remember we was talking about the plus and the minus? Well, there you go. Remember, one's going to be minus, one's going to be positive. So that they're inverted. That's going to be the negative polarity. This one down here, see where it says positive? That's going to be the one for the positive polarity. And of course, you can actually build your own. Let's say you bought a probe, custom probe. It's not in here, no problem. You can define your own probe. You can tell it what it is. You can define little equations for it to define how you want to set that up. So it's all customizable. Okay, so it's no problem on that too. And of course, when you see A, B, C, D, they're all the same. Okay. You can also set it up for measurements on if you want to measure voltages. Let's say if I want to add a measurement. Now, like say for channel A, let's look at that one. We got channel A. We can select the type of measurement we want. You know, AC or RMS. Well, for this case, it's not going to be that. But hey, maybe I want to see the DC average, duty cycle, falling rate, frequency. You got all of these different parameters that you can pick. Let's say I pick DC average. Okay. Now I can choose which section of the graph that I want to look at. Do I want to look at this whole trace? Yeah, sure, we'll do that. But let me show you other options. You can do it between the rulers. Maybe you got some little section you want to see what that DC average is. But in this case, I'll just do whole trace. So we come down and we look. And if you look at the bottom down here, it pops up a measurement for us. So 3.6 volts. Okay, now this would be good for you guys that has, say, a DC voltmeter. You know, they measure average voltages unless you got a true RMS meter. Most of the El Cheapos, you're going to be measuring average. So if I'm looking at this here signal and it's running, instead of me looking at 6.5 volts that we see here on the oscilloscope, you're going to be actually looking at 3.6 volts. Okay, so your voltage is going to be a little bit lower. Whole point is, you know, if you got a voltage there, then you pretty much, you know, your signal is okay. All right. And so if we wanted to go back and, you know, let's say we want to put another one in, and you can come right down to here. You click on it, and let's say let's do B. Let's do one more. Let's say we want to see the duty cycle. Let's see what the duty cycle of B is. So we look at it. And we look at the duty cycle, and it says 84%. Okay, so there you go. There's some of that stuff. And then if you want to get rid of it, then you can just say, hey, yeah, get rid of that one. And I got one more, and I say click there. Let's get rid of that one. Okay, all right, let's see. I'm trying to think of some other things here, some things that might be of interest. Now you got all of these different ones in here, just preset, but the recommendations is you know, go ahead and just get the scope running and set it up like you want it, because some of these things might be off a little bit, and if you're going to learn it, just go ahead and set it, you know, get the signals and then come back and just play with your voltages, your time base, ain't nothing. Change your sample rate. You know, another thing we can look at, if I say right mouse click and I want to go to view properties, then if I look over here, and I showed you this before, sample interval 1 microsecond. What that's saying is that it's saying, hey, how often do you want to measure a voltage? Hey, you know what? I want to see a voltage measurement every 1/1,000,000th of a second, and that's what we're seeing on the screen. So every millionth of a second, we're taking a voltage reading. Okay, basically, here's our sample rate. We're taking 1,000,000 samples a second. How many samples do I have on this? I got 200,000. Then we see the properties on the channels, like A. You can see this is A. My range, voltage range is plus minus 20 volts. Coupling's DC. That's going to be pretty much the same all the way down. So, and right here is where a demo where it was up before, where I had this signals. Anyway, so let's see what else we got. You can copy as an image, you know. You can. A lot of this stuff is just cut and dry. You know, you can kind of come back and see what you got there. Custom pro. You got math channels. Yeah, that's pretty nice. You can subtract, add, define your own things. Like, say, for example, if I want to invert, subtract, and do something there. Hey, but if that ain't what you want, guess what? Go in there and create your own. So you come in here. You want something advanced, you can get square root. You can do exponential equations, logarithmic, absolute values, frequency. You want to see the frequency of this. Hey, you want to look at a mass airflow sensor. You know, it's typically, like, say, a digital has a square wave pulse. Hey, put it on a frequency, and then you'll see it graphed. So there's a lot of stuff in here. But this is just the small things here, just show you guys. And so anyway, these signals look pretty good. Good gracious, where did the time go? It flew by. But listen, before I close this video out, I want to show you one more signal here, one more set of waveforms, and then we'll wrap this video up. Okay, now you remember I was talking about the power of PicoScope. Remember those long time bases? Well, this is where I had the car. I was running it for about 15 minutes, and what I did is I closed the hood. I wanted the temperatures up. I wanted hot. And if you look right down here in my lower right corner, you can see I had 16 minutes and 40 seconds that I was running this here scope, just trying to see if I could see anything that will fail while I had these here voltages, monitoring. So if you look at it, it looks like a bunch of gobbledygook, doesn't it? So let me get rid of these little things down here so we can open it up a little bit. So when you see this, what's happening is all of these here voltage waveforms are being compressed into this here 16 minutes and 40 seconds. So how do we get to look at it? Simple. We go up to our zoom tool. I got a zoom window, and then we're just going to zoom around it. So what we do is we just keep zooming, and you see how it's starting to open it up. We're starting to see some of these signals now. So now we're opening them up, and now you can see where we're at. So at this point now, we can just take and scroll across, kind of look at this stuff. Actually, let me just do this again. Yeah, so when we get this thing open up, I kind of lost my scroll bar because it gets a little bit smaller down here at the bottom. Okay, so then once you get it, you can kind of scroll through it, look at it. I can come over here. So now we can just go through all of these waveforms, and we can just start looking through all that stuff. But I've already looked through it. Everything looks fine. This is running the car, like I said, for over 16 minutes with the hood closed. Try to get that temperatures up. No problem. Anyway, guys, this video is getting a little bit long, so I'm going to close it out, and you guys stay tuned, and we'll look at some more waveforms. You guys take care.